You know, folks are always saying to me, Ron, everything always goes so smoothly on the show. It's never like that when I take on a home improvement project. Well, I can tell you, as a homeowner and a do-it-yourself guy, I'm not immune from the kind of surprises that are part of just about any home improvement project. As an example, I want to tell you about something that happened to me the other day. It all began when I came into the kitchen and turned on this faucet.
Instead of a nice, smooth, bubbly stream of water, I got a lot of spitting and sputtering. Now, I've seen this before, and it almost always means debris is clogging the faucet aerator. So I unscrewed the device, disassembled it, and sure enough, I found small white bits of material which I carefully picked out. Then I washed the aerator thoroughly and replaced it. But a few days later, the sputtering was back.
Then I went to take a shower up here in the master bathroom, but there was practically nothing coming out.
So I unscrewed the shower head, took a look inside, and found more of that same debris that had clogged my kitchen faucet. Then my washing machine stopped working. It wasn't getting any water. I unscrewed the hose and, sure enough, you guessed it. Well, it seemed like it was time for a little research. I got on my computer and did some poking around.
So my online research has led me to believe that the culprit in all this might be right there, in the form of something called sediment.
Now, sediment can collect in a water heater from dirt, sand, or minerals that are suspended in the water supply. Over time, these deposits can build up quite an accumulation on the bottom of the tank, cutting down on burner efficiency. Incoming water can stir up the sediment and send it to faucets, aerators, shower heads, dishwashers, clothes washing machines, and any other water-using appliance in the house. The online advice I'd gotten said I should flush my water heater and instructed me to turn my gas valve to the pilot position, connect a hose to the spigot at the bottom of my water heater, shut off the incoming cold water, open a hot water faucet somewhere in the house, and then twist open the spigot on the water heater. Sure enough, out came the water, and with it, quite a bit of what looked like sand and more of those curious white chips that I'd found clogging up my plumbing fixtures. It looked almost like fragments of plastic. I was baffled, so it was back online for some more research. To my surprise and amazement, I discovered that back in the mid-90s, some water heater manufacturers had, unknowingly, installed defective plastic tubes called dip tubes in thousands of water heaters. Over time, these tubes could disintegrate. It appeared that my unit was one of those affected, so I decided to take out my dip tube, inspect it, and replace it if necessary.
Well, this is not good news. This is the nipple that I took out of the top of the water heater. It's supposed to have a plastic tube attached to it like this called a dip tube. Well, in my case, that tube has actually broken off and dropped into the tank.
Now, if you could see inside the tank, you'd find the dip tube lying there on the bottom. And if you looked more closely, you'd see those tiny fragments of plastic scattered about, just waiting to be carried through my pipes and into my plumbing fixtures.
I can't think of any way I'm going to get that out of there. And as long as it's inside, it's going to continue to deteriorate and contaminate my plumbing system. So I think I'm going to have to replace the water heater.
Well, what started out as a sputtering water faucet has so far led to the need for a new water heater.
Come right over here.
So this is
Bernard at my local home improvement center listens to my story and then directs me to something called a tankless water heater.
So you're saying that this water heater can produce as much water as these? It's so much smaller.
Bernard explains that a conventional water heater works by keeping a tank full of water continually hot and ready for use. Tankless versions, on the other hand, only heat water on demand. When hot water is turned on anywhere in the house, the unit starts and water is brought up to temperature instantaneously as it continuously flows through the internal heat exchanger. Well, I'm sold, so I load my tankless water heater onto a cart and into my truck. Now, being the do-it-yourself type, I entertained thoughts of installing it myself, and perhaps I could have, but in the end, I opt for professional help. The first thing plumber Mike Iovana does is install a T and valve in my existing gas line. Then he and his partner Jim Morissette begin running the new supply line. This is called corrugated stainless steel tubing, and in many communities, including mine, it can be used in place of conventional black iron for gas lines. Now Mike and Jim move on to the water lines. First, they tie in the new lines to the existing ones, and then get ready to run the copper pipes the last few feet to the new water heater. These brackets, called bell hangers, will hold the pipes securely in place and prevent them from coming into contact with the walls. This will make it possible to apply insulation later and prevent chafing damage to the pipe itself. Before copper can be soldered, the pipes and connectors have to be cleaned to remove oxidation. Then, soldering flux is applied. This paste enables the solder to flow more evenly and prevents the copper from oxidizing again when it's heated. Next, the pipe and connectors are slipped together. The copper is then heated with a torch. When it reaches the correct temperature, the tip of the solder is touched to the metal. It melts instantly and is drawn into the joint by capillary action. Now notice how Mike has bent the solder into an L shape so he can easily reach all the way around the pipe. I've built this platform from 2x4s and plywood so that I can mount the heater about 4 inches out from the wall. This will allow the vent to clear the floor joists as it passes to the outside. After drilling holes using a carbide-tipped bit, I drive in these Tapcon screws. They're masonry anchors that actually cut threads into concrete. Once I've secured the platform cover in place, a single screw will allow me to hang the water heater on the front. Then I can drive in additional screws that secure the mounting brackets. Now the plumbers can come back to make the final hookups. First, Mike connects the gas shutoff valve and sediment trap. That's the short section of pipe running downward. Then attaches the corrugated stainless steel supply line. Jim now makes the last few connections between the water shutoff valves and the heater. Then does a final bit of soldering. With the gas turned on and the air bled out of the line, a sniffer is used to make certain there are no leaks. This is heat-resistant silicone sealant that I'm applying to the heater vent. Next, I slip on a connector and secure it to the vent with a hose clamp. Then I put on the first section of stainless steel vent pipe. Pull the retaining ring down into place and bend over the tabs that lock the ring in position. Next, I set a 90-degree elbow in place. Then, using a long shaft 1/4-inch bit, bore through the rim joist to the outside at a point that will be the center of the vent hole. Outside, I use the metal wall thimble as a template, tracing the outline onto the shingles. Using a spade bit, I bore a 1-inch hole near the edge of what will be the opening. Then, I grab a reciprocating saw, insert the blade into the hole, and begin cutting. Now, I need to remove a few shingles around the edge of the opening so that the flange on the wall thimble can set directly against the plywood sheathing underneath. The purpose of the thimble is to prevent the vent pipe from having any direct contact with wood as it passes through the wall. Silicone caulk applied to the outer flange will ensure a watertight seal on the outside. Next, I drill pilot holes through the stainless steel flange, then drive in screws that pull it into tight contact with the sheathing. Finally, I seal the screw heads and the building paper with more silicone. From the basement side, I slip the interior flange into place, attach another straight section, slide the retaining ring into position, and bend over the tabs to lock it all together. Now, from the outside, I slide through a section of vent with an elbow attached and connect it to the vent inside. Finally, I slip on one last vertical section of pipe on the outside with two 90-degree elbows on the end that form a U to prevent rainwater from entering. One last connection, and the vent is finished. The final job outside is to replace the shingles I removed earlier. All that's left now is to plug in the power for the thermostat and onboard microprocessor, insulate the hot water pipe coming from the heater, turn on the gas, and fire it up. Now, one of the obvious benefits of this system is that I've replaced a rather massive tank in my basement with a relatively compact unit that's up out of the way on the wall. But the real payoff is that I will now have enough hot water to wash the dishes, give the kids a bath, and take a shower all at the same time. In addition to the main thermostat, I also have a bedroom unit that allows me to control the water temperature remotely if I choose.
So that's my story of how a simple, sputtering faucet led to a discovery about sediment and defective dip tubes, which required me to replace my old water heater with new technology, which ended up providing us with unlimited hot water. Yep, there's no question about it. Home improvement can be a journey and an adventure.